Alright, so we're given here with matrix A and matrix B. We are asked to calculate rather the inverse of the product AB, the product of A inverse and B inverse, and the product of B inverse and A inverse. Pause the video and try to see if you'll be able to find these products. Alright, so first let us start with AB inverse. So, calculating AB inverse, that would mean that we would need to first multiply matrix A and matrix B, then we find its inverse. So, performing matrix multiplication here, we're just going to have the matrix 4, -3, 5, -4, then getting its inverse, which is actually 4, -3, 5, -4 as well. So this is our inverse of the product AB. Let's now look into A inverse times B inverse. So let's write it here. A inverse times B inverse, that would be equal to getting first the inverse of matrix A, then multiplying it to the inverse of matrix B, like this one. So the inverse of matrix A, which the solution is left to our viewers, would be 3, -2, -1, 1, while the inverse of B would be 1, -1, 1, -2. Multiplying these two, we're going to get the product 1, 1, 0, -1. So as we can see, the inverse of the product of AB is not equal to A inverse times B inverse. So we cannot say that these two are equal. So we cannot distribute this. What about B inverse and A inverse? So having B inverse times A inverse, that means that I'll first going to get B inverse, 2, -1, 1, -1 inverse, then multiplying it to A inverse, which is 1, 2, 1, 3 inverse. This would mean that I'm going to have 1, -1, 1, -2 here. Then here I'm going to have 3, there you go, 3, -2, -1, 1. And this will actually lead to 4, -3, 5, -4. So as you notice, the inverse of A and B gave the same result as B inverse A inverse. And this is actually a theorem. So if A and B are invertible matrices of order n, then AB is invertible. And the inverse of AB is actually equal to the product of B inverse and A inverse. So like what we've seen a while ago, here, the inverse of the product of AB is the same as getting first the inverse of B and multiplying it to the inverse of A. Take note that order is important here. It is, by the theorem, AB inverse is equal to B inverse A inverse. We had to interchange the order so we can get the same result. So, let's have an example. We're asked to find AB inverse for these matrices. Pause the video and try to see if you'll be able to find AB inverse. Alright, so first, you can actually just multiply AB as is, then get its inverse. So if we're going to do that, well, let's have multiply 1, 3, 3, 1, 4, 3, 1, 3, 4, then multiply to 1, 2, 3, 1, 3, 3, 2, 4, 3, then get its inverse, if that will be faster for you. So if we're going to multiply this first, we're actually going to get the matrix 10, 23, 21, 11, 26, 24, 12, 27, 24, and then you find its inverse by Gauss-Jordan elimination, since this is 3 by 3. In doing so, we're going to get the matrix 8, negative 5, negative 2, negative 8, 4, 3, 5, negative 2, and negative 7/3. Now, if you would like to find instead of directly doing this, you can also look for B inverse A inverse, which is practically the same thing. But instead of multiplying first, you find the inverse first. So that would mean, I'll write it here down below, we'll first have 1, 2, 3, 1, 3, 3, 2, 4, 3. Find its inverse, then multiply it 2, 1, 3, 3, 1, 4, 3, 1, 3, 4, then find its inverse. So the inverses of these two matrices would actually become, this becomes 1, negative 2, 1, negative 1, 1, 0, 2/3, 0, negative 1/3 here, while this one becomes 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0, 1. In turn, we're going to get our product as 8, negative 5, negative 2, negative 8, 4, 3, 5, negative 2, negative 7/3. So whichever you find easier, multiplying first, then getting the inverse, or getting the inverses first, then multiplying, you will be having the same result provided we follow our theorem for the products of inverse of matrices.